Hello everyone. Now I am just going to start the numerical from first. I shall start from the vector resolution. Okay, the first numerical. This is vector resolution. First numerical is as a force has magnitude. A force has magnitude a force has magnitude of 15 Newton of 15 Newton, right? Direction of F is at 37 degree from negative x-axis. Negative x-axis. Right, towards positive y-axis, towards positive y-axis. This is actually magnitude of F is equal to 15 Newton, right? Represent F in terms of represent vector F in terms of I and J cap. Okay. Now, first let me draw the diagram. This is y-axis. This is origin. X-axis, y-axis. Force has magnitude F of 15 Newton. Direction of is 37 degree from negative. This is the negative x-axis. This is 37 degree. Towards the positive y-axis. So this is the force, right? Now component of F along, if I resolve the force, this is actually the arrow, direction of force, it is resolved along the negative x-axis. It gives F cos 37 and this gives F sine 37. Here it is very clear. F37 is directed along negative x-axis and F sine 30 is directed along positive y-axis. Along positive y-axis. Right. Now this F, as we have learned from the theory, F is nothing but Fx along the x component, Fy along the y component. Right. Now Fx, this is mod of Fx I cap plus mod of Fy plus k cap. Fx is what? Fx is F cos 30 degree. F cos 37 degree. I cap. This is along the negative x-axis, so it would be minus I cap. Right? And Fy, F sine 37 degree. This is along the positive y-axis, so this is positive k cap. Now F is what? F is given 15 Newton. Let us put 15 Newton. Fine. Now cos 37 is standard value is 4 by 5 minus I cap. This is 15. Sin 37 is 3 by 5 k cap. Okay. I have just put the values. So it would be, after simplifying, F is 5 goes 3 times, 3 into 4 minus 12. Minus 12 I cap, minus 12 I cap. 3 plus 9, actually along the y-axis, not k cap, along the y-axis j cap. My God, along the, this is j cap, this is j cap, right? So 9 j cap. This is the final answer. This is the final answer. Along the y-axis, positive y-axis, positive j cap. Along the negative x-axis, minus I cap. Right? Another numerical from vector resolution. Resolve a weight of 10 Newton. Resolve a weight of 10 Newton in two direction. In two directions. In two directions which are parallel, which are parallel and which are parallel and perpendicular to the perpendicular to a slope, perpendicular to a slope, perpendicular to a slope, inclined to 30 degree, inclined at 30 degree to the horizontal, right? According to the question, first we shall draw the diagram, right? This is the inclined plane and this is the horizontal line, right? This is the inclined plane. Angle is 30 degree. Let me repeat the diagram. This is the inclined and this is 30 degree. Okay? So weight. This is the weight. Weight acts vertically downward. Weight is 10 Newton. This is the normal, which is perpendicular to inclined plane. This is inclined plane. This is normal to inclined plane, right? This is normal to inclined plane. Now if this is 30, this is 90, so this will be 90 plus 30, 120, total is 180, so 180 minus 120, 60. This will be 60 and this 90, this is perpendicular to this one, so obviously it would be 90 minus 60 is equal to 30 degree. Right, so if it is 30, then this angle is also 30 degree. Right? This angle is also 30 degree. Now, let me redraw the diagram so it would be very clear now. So, if this is a body of weight 10 Newton, this is the vertical line, this is the perpendicular line to the inclined plane, perpendicular to inclined plane, right? If this is 30 degree, this also will be 30. Now this is the weight 10 Newton, right? Now we have to find out the parallel and perpendicular component, right? If this is resolved along this line, it would be 10 cos 30 in accordance with the theory of resolution. Since this vector is inclined 30 degree to this line, so along this line component will be of cosine, right? And perpendicular to this one, this is this line, this slope, right? It would be 10 sine 30. Okay. So component parallel to the plane. This is the inclined plane. This is right. Component parallel to the inclined plane. Parallel to the inclined plane, right, is 10 sine 30. 10 into half. Value of sine 30 is half. This standard value 5. So it would be 5 Newton. Right? Now, the component along the perpendicular. Component perpendicular to the plane. This is the inclined plane. This is inclined plane, right? And this one is perpendicular and component is 10. So component perpendicular to the inclined plane is 10 cos 30. The value of cos 30 is root 3 by 2. 10 root 3 by 2. This is 5. 5 root 3 Newton. Right? 5 root 3 Newton. So finally answer is parallel to the inclined plane 5 Newton and perpendicular to the inclined plane 5 root 3 Newton. Okay, this is the final answer. Fine. I expect that all of you have understood very nicely. I have explained all the steps very clearly. These two numerical problems are chosen from the concept of vector resolution. In the next class, I shall start the numericals from nucleus-based numericals problem based on scalar product and cross product. Thank you for watching my video.